guys, I actually want to look at example 7 first. It's on that next page, this roller coaster problem. So this is just a real life application of how we use polynomials. So it says during the first 5 sections of a roller coaster ride, the function h of t equals 4t cubed minus 21t squared plus 9t plus 34 represents the height in feet of the roller coaster after t seconds. How long is the roller coaster at or below ground level for the first 5 seconds? That's our ultimate question. We also want to answer all of these questions. Shh, listen up, please. So this is our polynomial function right here. Now, it says that it's only applicable for the first 5 seconds. I actually want to ask this question first. Why do you think the function is not accurate for the entire time the coaster is traveling? What do you think, Krish?
Because according to this function, the roller coaster will be at the start will have gone down forever, and then afterwards at x equals 5, it'll be going upwards forever.
Right, and that doesn't make sense. I don't want to be on any roller coaster that goes up to infinity. I don't know about you, but I don't know. It doesn't sound fun. So the ends are going to negative infinity and positive infinity. So that's the reason why it's not accurate for the entire ride. So it's telling us that it's only accurate for the first 5 seconds. I actually want to come back to this question at the end. Let's go to this one first. What is the height when the ride begins? How do we figure that out? What do you think?
Where x equals 0 and the equation is
Okay, so we can look at the picture, but it's kind of hard to tell from the picture. So what if we plug in t equals 0? What do we get if we plug in t equals 0? 34, very good. You guys did that fast. So 34 feet is the height when the ride begins. Then it says, yeah? Yeah, the constant, because if we plug in 0 for t, all these other terms just go away. So now it says, what is the lowest point that the coaster goes? Can you tell exactly what that lowest point is? Maybe negative 20, but I can't tell for sure. So what would I have to do? Yeah, I would have to put this into my calculator. So here's what I'm going to do. I'm going to type this in here. We have to use x's. Don't use t's, use x's. You can just watch. You don't have to do it on your calculator. Now, my window's set up. If I do a zoom 6, here's what I see on the standard screen. That's not great for me to see. So I'm going to have to figure out something else for my window. Zoom what?
Zoom out.
Okay, I just like to adjust the window by hand because I have this picture. So like what the times are fine. I mean, negative 10 to 10 is fine for the time. But for the minimum height, how low does it look like it's going?
About 30.
Yeah, we should probably make this negative 30. And then the highest point, well, I can see 80. I might want to do 100. Okay, so now when I hit graph, here's what I see. Okay, and so now it's saying what is the lowest point that the roller coaster goes. So that's right there. So I'm going to have to do second trace, calculate what? The minimum. So I'm going to have to go to the minimum, and I'm going to have to move over close to that minimum, and it's going to say left bound, enter, right bound, move over to the right, enter, and then one more time. So is this the lowest it goes, or is the y value the lowest it goes?
The y value.
Okay, so it goes all the way down to 21.26. I'll round to the nearest hundredth. 21.26 feet below ground. See right here, this is ground level. Then it says, what is the coaster's height at 5 seconds? What would I do to figure that out?
I can choose values and then say 5.
Yeah, so I can plug in 5. There's a couple of ways to do this. Here's the way I like the best, is just to look at the table. Do you guys see that? Second graph takes me to the table, and I can see that when t is 5, I can see what the height is. So that's a nice feature. So 54 feet up in the air. And now let's go back to this question. How long is the roller coaster at or below ground level in the first 5 seconds? Well, here's one place, and here's the other. I can't tell for sure exactly what those times are. What is the height when it's at ground level? 0. So I'm going to put in y2, I'm going to put in 0. And now I'm going to hit graph again. So I want to know how long is it? How long is that it's below ground level? So I'm going to do second trace, calculate the intersection, and I'm going to come over here and I'm going to go there, enter, enter, enter. So the first time is at 2 seconds. And then the second time, I'm going to do second trace, calculate, intersect, get over there close, and I'm going to do enter, 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 4.25. That's the second time. So for how long, guys, is it below ground level? Right, 2.25 seconds. Okay, so that's just like one of those real world application problems that they always have at the end of big ideas. Chris?
So would the x-axis be like sea level, or would that just be like the ground?
Ground level. Like, you know how some roller coasters go underground because they might have a tunnel or something? That's what that means. Yeah. Anybody else? Questions? All right.